So basically today I wanted to walk through the components inside a modern quadcopter. Now these things change all the time, of course, and this is as of a 2015, but there's a few major components that makes up a quadcopter. Now I'm not an expert builder, I'm not claiming anything like that. But I'm in the middle of a rebuild of this quadcopter over here. I have already a lot of the soldering done, so this isn't a build video. This is more a what are the components video inside a quadcopter. And I know most of us know this, but for a beginner or a new guy, this might be helpful. So I broke it up into sections like this. This is the frame section over here. And there's many frames out there, and we'll discuss that a little bit later. This is the main electronics section with the power distribution and the ESCs and the motors and the power cable. That's all your power stuff. And of course the propellers that go onto the motors. Then this is the main control board. That's the main control of flight controller, and there's many of those. And that's the guy that talks to your radio, your receiver, that you control this quadcopter with. And then there's other things like missing alarms and a little bit of cables. And on this side we have more of FPV, if you want to add FPV transmitter and antenna and some cables that do the power. So that's sort of a setup. The frame, the FPV stuff, the electrical part of it, the propellers, the control part, and miscellaneous stuff. So if you start by the frame, in this case this is a Morphite frame, Morphite 180. Typically there's a base plate like this on all frames, and again there's many frames. There's ZMR frames, which is very popular for beginners now, and many there's 1,000 different of these frames made of different material. This guy is made of carbon fiber. And carbon fiber is a very light material but very strong. And they come in all sizes. This guy is 180, meaning the distance between two of these motors diagonally is 180 millimeters. So 180 and 180. The distance between the motors will be 180 millimeter, and that makes this a 180 class. There's a 250 class, there's a 300, 330, 450, and it just goes from there. And this is also a quadcopter, meaning it has ultimately 4 motors, so that makes it a quad. There's ones with 6 motors, and that's a hex, or 8 motors, that's an octocopter. So there's as many frames and configurations as there are. In this case we'll build the more common quadcopter, the 4 motor version, and or we'll explain it and see, the specific one is in the 180 size. So again, that's the frame, and on the frame I'll go the 4 motors, will go each there, and typically this is called the base plate, and on there typically you will add standoffs, and those are little plastic standoffs that will go on here that will host some of the electronics. Now carbon fiber like this is very conductive. So again, this frame is made of carbon fiber. You get others that's made out of G10, and that's made out of fiberglass and even plastic, and of course wood. Those aren't as electrical conductive, or however we would put it, but this guy is. Meaning electricity, if you were to hold a battery, one pole on this side and one pole on that side, it would short out. So on a carbon fiber frame, it's very important to look at using things like plastic standoffs so that it can isolate the electronics, this, from the frame, because if it touches, it will short out. Now with other frames like wood frames or plastic frames or G10 fiberglass frames, that's not so much of a worry because it's not, electricity won't flow. So that, again, that's a frame. Then it has the base plate. Typically on top of a base plate then goes the standoffs, and on top of the standoffs we'll mount and that's called the power distribution board. We'll get to the power section now. Then a frame typically has a top plate, which in this case is that guy. It might have some accessory plates, and it might even have a bottom plate. So it's typically nowadays made up out of 2 or 3 plates that's stacked on top of each other. So that's typically what a frame is and what it does. It brings it all together, if you want to put it that way. Now, what is in a frame? That's a big discussion. People say my ZMR is faster than your. A frame is a frame. It's your confidence in the frame, how you feel about the frame, and how strong the frame is. That's things that make a difference in a frame. There is a little bit of an aerodynamic factor to it, but for most people it doesn't really matter. It's how the frame is, how you feel about it, how strong it is, and how easy it is for you to build on it. Size wise, 180, 250. For beginners, I wouldn't suggest building a 180 because, everything's pretty small. A 250 gives you much more space to play around with and do stuff. So let's move on to the electronics. The electronics is typically built up out of, in this case, because we're building a quadcopter, 4 motors. And again, the motors vary in size. These are tiny 1304 motors. Typically on a quad you'll put 22 motors. So 13 really is the diameter. 22 would mean it's a bigger motor in its diameter, or a 18 or a 22. So maybe on a quad like this you can easily run 1804s, which means they're thicker or bigger around, or 2204s, meaning they're even bigger than that. So this is a 13 motor, so it's very small in diameter. And then the second factor, and this is a 1306, is the height, the 06 part. So a 04 motor is pretty flat, a 06 motor is higher, a 08 or a 012, they all go up higher like that. So typically if somebody says this is a 1306 motor, you'll be saying it's a 13 diameter and 06 high, or a 1806, meaning it's rounder like this but about the same height, or a 2204, meaning it's a 22, so it's bigger around and flatter. Now each one of those has its own pluses and minuses, and there's a whole section about that. But typically on a small guy like this, we want to put a little motor, so I'm going to put a 1306 on here, which is a good motor for this size copter. A 250 can maybe take a 1806 or a 2204, which are about equal. The 1806, it's a taller motor, and the 2204 is a flatter motor but wider. And there's many pluses and minuses to those. And this other factor to a motor is its speed, and that's its kV rating, how fast it spins. But and in this case, this is a 3100 kV motor, so we want to spin it very, very fast. Those little props over there. But again, on a typical 250, maybe that speed will only be 2300 kV. So, and that's how fast the motor spins. So the motor is typically connected to what's known as an ESC. Again, there's a myriad of these. In this case, it's BL20A ESCs, and it's a 20 amp ESC. These motors typically draw no more than 6 amps or so. So this is a very big ESC for the motor, but these ESCs are very small and they fit this frame very well. So typically you would want to never exceed, the motor should never draw more amps, and you can get those specifications on the motor with the motor specification. When you buy it, it will tell you what's the max amps it will draw, and from that you will determine what size ESC you will use. And nowadays these BL20 or SN20As are great because they go up to 20 amp, and these motors will never exceed 20 amp draw. Then all of the wires are connected, power wires are connected to this thing, and that's called the power distribution board. And this power distribution board typically brings in voltage from the battery, and then it might contain, this guy has a little polulo on there, and that is a voltage regulator that will drop the voltage. We might put a 12 volts in here, or 14 volts, or and that will drop it down to 5 volts, and the polulo will produce for us an output of 5 volts on this wire, and that 5 volts is what we'll use to drive the other electronics, and it will also provide power from the battery connector to each one of these ESCs, and that's how the power distribution works. So all the power, all the positives go together, all the negatives goes together, the battery, so each one of these ESCs, all 4 of them, will receive a power, and that the ESC is typically rated for a 2, 3 or 4 cell. Typically nowadays everything's at least 4 cell capable, so the battery voltage goes straight in there, and then there's a little voltage regulator that will turn that 12 volt or 14 volts into 5 volts, which we need for that computer, the main computer or the main processor. So that's how that works. The propellers, of course, go onto each motor, and there's a direction to each one of those propellers, and it depends on how this is configured. So moving on, we've got the main computer, and in this case it's a CC3D. Another popular one is a NAS 32. There's many of those kind of computers nowadays, or as they're known, flight controllers. So again, the 5 volts will go in there, as well as the signal wire to each one of the ESCs will also plug in there. And the basic idea is that this guy, the controller, has sensors on to know what the level is of a copter, of a quadcopter. It knows when it's level, and it knows its state, and it will basically, there's a processor on there that runs software that will tell each one of these ESCs what to do with its connected motors. So for instance, if you wanted to, if a board is tilted forward, it will tell these 2 motors to spin up. The main computer will let these 2 ESCs know that it needs more lift or more power from these 2 motors, and these motors will lift up and spin faster than the other motors, and thus it will level again. So if it falls backwards, the same scenario. Okay, so then the next thing is, of course, from here I typically run PPM, which just means it's a single wire interface with voltage to my receiver, and I'm using a FR Sky receiver here, but this receiver basically receives the signal from your radio. So the typical flow is, I will tell the copter on my radio to move forward, let's say. It will be received by the receiver. The receiver will pass that movement request onto the main computer over here. The main computer will then pass that request on to maybe the 2 back motors to speed up, and thus the copter will lift up forward, and I will be moving in a forward direction. And the same goes for left and right, and this guy, of course, at the same time keeping everything level. So that's the main idea behind this guy. It's the main computer. There's a processor in each one of these that do a lot of work, that basically convert, you know, the signal into voltage that drives these little motors. So that's the basic idea. Then another thing I typically add is a missing alarm, and that guy I can trigger with a switch from my radio. I can tell it to turn on. So if I crashed in the woods or in long grass, I can tell it to turn this little beeper on, and I can find it. So that's always important for me to add one of those. So that covers the frame, the electrical part and the motors, how the power gets there, the propellers, the main computer, the receiver, and some other components. And then there's just the FPV part left over here. And this really is, you can or you don't have to put that on a copter. This is sort of optional. A quadcopter would fly with those. Of course, what's missing still is a battery. I mean, that would plug into a power connector like that that's connected here. But with that, you can fly what's known as line of sight. You can fly the quadcopter in front of you and do just fine. If you add this piece, this is called FPV, and it stands for first person view, and that typically consists out of a FPV a camera. First of all, this is a little camera. And that's a FPV transmitter. So typically what happens here is, you know, the camera receives a signal, or it's like a normal camera, that will send it into the transmitter, and the transmitter, there's a receiver, this is a transmitter, this will transmit out all what the camera is viewing, if you want to put it that way. And then, of course, you can receive that on a monitor or your goggles. So this allows you to fly the copter without having to look at it. You can fly it behind a tree or something like that, and you'll be looking outside this through this little camera as if you were inside the quadcopter, and or you were actually piloting it. So this is a very modern you know, aspect of the sport, is adding FPV, and it really is only this piece. It's a camera and a transmitter, and then of course you need the monitor or the goggles or something like that on the other end. These guys also come in a myriad of configurations. You can add what's known as an OSD in the middle here, and that OSD sometimes can talk to your computer over there, and then it will overlay information about your battery voltage and your location. It will overlay that on top of a video signal, so you can add an OSD in here to give you information. So if you're looking on your goggles, through your goggles or a monitor, you'll be able to see some vital information about what's going on with the quadcopter, like what's the battery voltage, or my location, or my speed, or my height, that kind of thing. So, but typically a small quadcopter like this in a 180 size, you wouldn't add an OSD because, you know, every gram or so makes a difference. So that's the basic overview of a quadcopter, a modern quadcopter today, and how it's built. And let me know if you've got any questions or I can help with anything. Thank you.